Hello, and today we're going to teach you on how to use a debugger to troubleshoot your programs and how to effectively use it to help out and remove some of the headaches that are normally associated with programming. Here I've written a very simple program that loops through the numbers 1 through 100 and prints out whether they are old or young at that age. But it has this very small bug. And so let's first run this without any debugging and show you what that bug looks like. So now, as you can see, it's got the numbers and it's printing out whether it's not old, or it's not very old, or is very old. But here we've got a little bug here. And that wasn't expected. We kind of expected it to print out a line that says it's not old, and then it goes on to 13 and prints out a second line, but it's kind of joined these lines together. I'm going to show you how you can actually step through with a debugger and see what's happening as the program is running, which is a lot nicer than just kind of trying to read through the code and see what it's doing. So the first thing I'm going to show you is a breakpoint. Now a breakpoint says run the program, but as soon as you reach this line, pause. So let's try that. To start our debugger, we can either go to the debug menu and say start debugging, or use its shortcut, or there's also this button here to do the same thing. So let's run our program. Now our program was running, that's this window here, but as soon as it hit this line, it paused, and it has not executed this line just yet. It's waiting for us to make a decision call. So we can actually go in and we can take a look at variables while it's in this pause state, and I can see, oh, the variable age has the value 1. I can also look at this window here. This is the autos. It tries to pull up a list of all the variables of significance. You can also say the local variables, which are the variables that have scope. You can also look here in the watch, and you can add in anything that you want to just by typing it in. And of course you have this trick where the tooltip can look at a variable. Those are all pretty useful. So now from here I can tell it to continue, and it will continue to run the program until it hits another breakpoint. And we'll see it's already executed this line, so it went and it called the function and printed out, and then it came back and looped, and it was paused here again. It's now age is changed value. You'll notice when the value changes on our watch here, it turns to red. That's just a little indication to show that the value has changed. So we can still see that while we're paused, we've done our loop once. There's another way you can kind of control the flow of the program, which is stepping. And those are these buttons here. This toolbar here is the debug toolbar. So our options are to continue. If our program is running, we could tell it to break. Sometimes that's useful. We could stop debugging at any point. Right now let's go through these step functions. So the first one we're going to look at is just step over. Step over tells it to do a single line of code. So if I hit that button, it's going to step to the next line. And so we will see that it has printed out our age, which is value 2. Now if I tell it to step over again, it's going to execute this entire function. It does not go into the function whatsoever. It just steps over one line of code, and this is one line of code, so it is now at the end of our for loop. And if I look here, it has filled in the rest of our thing. So now if I wanted it to kind of see what happened inside of that function, I won't use step over for that. What I'll do instead is I'll say step into. So while it's on this line and it hasn't executed yet, let's do this other button, step into. Now you'll see that the flow of the program has gone into our function. And we can still see the variables at this level, so I can continue to say step in or step over, And since I'm not on function calls, they make no difference. Step into, if I had a function call here, would step into something. Let's see. You might run into this. If you hit step into while calling a system function like cout, which belongs to the OStream class, it'll take you into some code that's not your own, and it looks rather strange. And so here's a way you can deal with that. This last one here is called step out, which steps out of the function. It doesn't go to the next line, it goes to the next part of code that is outside of the current function. So if I hit step out, I expect it to get out of this OStream or cout code and back into our own. And it has. And it continues to have the tab there. We can just close that. So while you're in your own functions and you're not making function calls that you have written, probably should just default to the step over. So if I do that, it will execute that line, and I have our third line for the value of 3. Now I can also check this against other things here, and I can see, oh, it didn't match this condition here, so it's stepped completely over this block of code, which we were expecting. 3 is not in between 12 and 70. Another thing you can also test is whether it will go into the functions by adding breakpoints. You can add and remove as many breakpoints as you feel like at any time. It works just fine. You can even tell it to remove all breakpoints and disable all breakpoints, so that you have quite a bit of control over that. But let's get back to the issue at hand. We were having a problem with our code when it was at the age of 12 and 13. And right now we're looking at our loop when the age is 4. Now we could just, press this continue button a few times, and then it would eventually get there. We're at 6. But let's do this a little bit smarter. So the next thing I'm going to show you is a condition. For every breakpoint you have, you can add a condition to it. And so let's add a condition for when age is equal to 12. Now if we hit that and hit our continue, and now we see that it matched the condition on our breakpoint, so it chose to stop. So now we're at our condition of interest. We want to see what actually happens to this code with the value of 12. So we can step over this line and step into our function, and we'll monitor this carefully. We want to see what exactly is happening and see if it's going to do what we expect it to. So we step over, and now we're at our condition. Is 12 not too old? Is 12 too old? Let's find out. It steps over this, and that's because 12 is not less than 12. But it also steps over this one because 12 is not greater than 12 either. So what I probably should have said is, for this condition, if age is less than or equal to 12. And that will fix our program. So now we can stop. Let's remove our condition and just run our program. And go back up. And now we see that our program is fixed. So being able to step in and out and through and adding conditions for when we want to pause our program should help in the future when we're trying to solve certain problems. And that will be all for this lesson.